Hi everyone. Today we're going to study directional derivative. The directional derivative of a function f at a point P in the direction of the unit vector u is given by the formula df over ds equals grad f dot u. Remember that grad f equals I times partial derivative of f with respect to x plus j times partial derivative of f with respect to y plus k times partial derivative of f with respect to z. For the u, this is equal to the vector v all over the length of v. This is the working formula. Now, for the formal definition, we have the directional derivative of function f at the point p sub 0 of x sub 0, comma, y sub 0 in the direction of the unit vector u equals u sub 1 I plus u sub 2 j is the number, and this is our limit formula, provided the limit exists. Now example 1, find the directional derivative of f of x, y, z equals x squared yz plus 4xz squared plus xyz at point 1, 2, 3 in the direction of vector v equals 2i plus j minus k. We write here the formula for the directional derivative, that is df over ds equals gradient of f dot u. For step 1, let us evaluate the grad f. So the partial derivative of f with respect to x is 2xyz plus 4z squared plus yz. This quantity multiplied by I plus partial derivative of f with respect to y, that is x squared z plus xz. The quantity is multiplied by j plus partial derivative of f with respect to z. We have x squared y plus 8xz plus xy. The quantity is multiplied by k. Now at 1, 2, 3, which means we substitute the value of x as 1, the y as 2, and the z as 3. The graph f is simplified into 54i plus 6j plus 28k. Now step 2, let's evaluate the u, that is equal to v all over the length of v. So we have here u equals, we copy the vector 2i plus j minus k all over the length of the vector. We have now 2 square plus 1 square plus the square of negative 1. We can simplify the denominator into square root of 6. Then let us distribute the square root of 6 or the denominator to each of the terms of the numerator. So we have 2i over square root of 6 plus j over square root of 6 minus k over square root of 6. Now step 3, we are now ready to evaluate the df over ds, that is grad f dot u. So we have this 54i plus 6j plus 28k dot 2i over square root of 6 plus j over square root of 6 minus k over square root of 6. So we have now this 54 times 2 over square root of 6 plus 6 times 1 over square root of 6 plus 28 times negative 1 over square root of 6. We can simplify this into 108 over square root of 6 plus 6 over square root of 6 minus 28 over square root of 6. And the final answer here will be 86 over square root of 6. Example 2. Find the derivative of f of xy equals x e raised to y plus cosine of the quantity xy at the point 2, 0 in the direction of v equals 3i minus 4j. We write the formula for the df over ds. Now for step 1, let us evaluate the grad f equals I partial derivative of f with respect to x plus j times partial derivative of f with respect to y. In here, we don't have the k. So we have now the partial derivative of f with respect to x as e raised to y minus y times sine of the quantity xy. So we write here the I. Then plus the component j times the quantity partial derivative of f with respect to y. We have x times e raised to y minus x times sine of the quantity xy. Simplifying this, we substitute the value of x as 2, we substitute the value of y as 0 respectively. The value of the grad f is simplified into I plus 2j. Now let us evaluate u equals v over the length of v. That is for the step 2. So we have u equals, we copy the v, the 3i minus 4j, all over the square root 3 square plus the square of negative 4. The denominator is simplified into square root of 25 and that is equal to 5. Now let us distribute the denominator 5 to each of the terms of the numerator. So we have 3i over 5 minus 4j over 5. Now step 3. We are now ready to evaluate the df over ds. Let us substitute the corresponding values. So we have I plus 2j, 3i over 5 minus 4j over 5. And this is equal to 1 times 3 over 5 plus 2 times the quantity negative 4 over 5. And this becomes 3 over 5 minus 8 over 5. That is simplified into negative 5 over 5. And this is equal to negative 1. This is the final answer. I hope you learned something from this video. See you again next time.